This particular little guy here is an orchid bee, and it's a supreme example of a very functional colour. The colour that we are seeing here is pretty highly advanced, really. It's not an ordinary pigment-based colour. It's a colour that arises with the way that light interferes, the way that light waves, if you like, interact with tiny structures, microstructures that are present, that have evolved around this animal's integument. Notice the very red arse. I mean, I can't get this arse word on hand. But this is a warning sign right here, and it shows a very elegant transition of colour from here through to there for functional reasons. So let's get on. The first is this first paragraph on page A. You don't get many alphabetical page letters. Page A, this opening paragraph. Let me pull it out here. This tells us about the scientific method. And those are two words, scientific method. Might not mean very much if perhaps you're not in science, but it is hugely important to the conduct, to the proper undertaking of science. He said, my design is not to explain properties just by hypothesis, but to propose and prove by reason and experiment. That phrase sums up the essence of what good science is about, what good research is about. And in physics and engineering and all across campus at Exeter and around the country and around the world, good scientists will use proper, correct scientific method. So I just wanted to throw that in because that underpins a lot of what you see both in the media, what you see today, and throughout your lives. Let's have a look at this. So following up on Newton, this is an artist's impression. So he drilled a hole in his wooden shutter here, put light through a prism, and the prism dispersed the light and produced a rainbow. So I've got what used to be a very nice prism here. This is it's not a tricky experiment to do in the right conditions, but if I were to hold this up to that light, yeah, there it is, okay. So we sort of get a little spectrum going here, not a very good one necessarily, but enough to say, oh yeah, the white light coming from there is split up, is made up, right, of all the colours of the spectrum that we can see. Now Newton employed this good scientific method, not just to do this experiment, which was very novel at the time, but to do an even more fundamental experiment. This is his drawing. Not only did he do that, but he took red coming off here, let's say, and he's asked the question, what's red made? Is red light actually a combination of many other colours too? And so he drilled a hole in this screen and he put another prism behind it. So you may not have noticed that prism there, but that's part of the greater experiment there. It's a sign of the man, a sign of the scientist employing this very good scientific method. The other means of colour production is this. And this is just a wave at sea, and it's a crashing wave, and colour is produced. Bioluminescent colour is produced. You may have seen this yourself if you visit the sea, or if you live by the shore or take holidays by the shore. This is the production of light by tiny little creatures called dinoflagellates, and they use a chemical which, when mixed with oxygen, in the right temperature environment, will bioluminesce, and they'll produce this wonderful blue as a result of oxygen being mixed, usually due to the crashing of waves. A great anecdote that I recall that I was told is that the last submarine to be sunk in the Second World War was spotted by a ship due to the bioluminescence coming off its bow wave. So let's move on. We've got this idea of pigmentary colour, and that's all over natural systems, all over biology. Very often, it's more than just this. Okay, I would look at that and with a sense of wonder, with a sense of awe sometimes, but it's static. The colour doesn't change. There are animals out there in which colour is really dynamic, and I'd like to show you one here. So this is a squid. George, maybe dim the lights a little bit actually. So these are, if I have a little sort of mole of dark colour on my hand or my arm or my face, that's because there's a cell that's producing melanin. Now, in the same way, these are cells that produce a particular colour. Some of them are red, some of them are pink, some of them are a great variety of colours, but the really amazing thing about this is that the shape, the geometry of those cells is controlled neurally by the screen. So it's the same volume of absorbing pigment. Absorption, that's what creates the pigmentary colour. But the volume is either really long and pencil thin, pointing away from the surface, or it's really flat and pancake-like, just underneath the surface. And the very last section, this video is about 1 minute long, the very last section is the most amazing of all because you can see how the cells, the chromophores, are controlled. Now there are various colours. There is a whiteness underneath caused by a protein or the lutein. Look at this, can you see the little pulleys, the little collagen fibres that are pulling this? It's just amazing. I think that one there, yeah, blows up. The control that some of these biological systems have evolved is tremendous. And that's something we really like to learn from, particularly when it comes to this animal. Now you may or may not have seen this animal. If you haven't, try to have a guess as to where the animal is and what it is. This is the potential that you have in studying some of these animals. And that's why it's so valuable, I think, to not overlook biological appearance control mechanisms, but to learn from them, to try to get them to inspire the research that we